Hello Math130 students, we are going to pick up on page 12, section 4.4, dividing polynomials and polynomial functions. So right now we are going to be dividing monomials, and later on we're going to be dividing a polynomial by a monomial. So what we want to do is we want to find the quotient. So for example number 1, before we can do that, we are going to have to simplify the expression a bit more. So my numerator is going to stay the same. There's nothing I can do there to combine like terms. So I have a 6 times a u to the 12 times a v to the 5th power. Down at the bottom, I have this parentheses, and I have these parentheses. But everything is just being multiplied. So I'm going to rearrange the order here. I have a negative 12, and I have a positive 2. And usually what I like to do is once I use the numbers, I like to cross it out. So that way I know I don't have to rewrite any of them. So then I'm going to deal with my u's. So I have a u to the 4th power. And then I have a u by itself. And then I'm going to be dealing with my v. So it looks like I have a v to the 8. And I also have a v to the 8. So now I've used everything up. So now I want to simplify this a bit more. So I have a 6u12 v5 in my numerator. In my denominator, I can multiply my negative 12 times 2, which is going to give me a negative 24. And now I'm going to combine my u's together. So u4 and u1 is going to give me a u to the 5th power. And then I also have a v8 and a v8. So 8 plus 8 is going to give me a v to the 16. And now I can simplify this a bit more. So I have a 6. I also have a negative 24. So if I have negative 6 divided by a positive 6 divided by 24, I'm going to get a 1/4. And it's negative. So now I'm going to be dealing with my u's. If I deal with my u's, u to the 12th is bigger than u to the 5th. So I know I'm going to have u up on top. So 12 minus 5 is going to give me a positive 7. Now I'm going to be dealing with my v's here. V to the 16 is bigger than v to the 5, so it's going to say my denominator. So 16 minus 5 is going to give me 11. So really my answer is u to the 7th over a 4v to the 4. And the negative can either be on top, on the bottom, or to the side. It does not matter. So that ends up becoming my quotient. Okay, I have divided this expression. Now for number 2, since it's written this way with the division sign, you want to think about that whatever comes behind the division sign, this is going to be your denominator. So when you rewrite it, you really have 9n to the 5th plus 14n to the 4 minus 6n squared, and everything is going to be divided by that denominator, by that n squared. But now I see that I have 3 terms because they're separated by addition and subtraction, so I'm going to break them up into 3 fractions. So I know that the fraction has to have the denominator of n squared because that was my denominator. I'm just breaking up the addition and subtraction. So my numerator stays the same. I still have a 9n to the 5th power, a 14n to the 4th power, and a 6n squared. And I took care of that plus an addition. So now it looks like I have 3 mini division problems that I'm going to deal with. So with this first fraction, I have a 9, and I have n to the 5th and n squared, so that's going to give me an n to the 3 in my numerator. so I don't really need that fraction anymore. Now I have a plus a 14, n to the 4 and n squared would give me an 4 minus 2, which is an n squared. Minus 6 and n squared over n squared cancels out. So that's how I'm going to get my final answer of 9n to the 3 plus 14n squared minus 6. Now what we want to do next is remember how to do long division. So remember, when you do long division, you divide, you multiply, you subtract, you bring down, and you repeat, right? So for example, if we have 11 divided by 2, then I know that I have 11 and my denominator is 2. Oops, that's not what I wanted to do. So when I rewrite this in long division, the denominator is going to go out in front. So I'm going to have 2 that goes into 11, okay? So let's think about this. Well, does 2 go into 1? No. But 2 go into 5, right? Let's actually make that a brighter color. How about a green? 2 times 5, right? I'm dividing. 2 goes into 11 how many times? 5 times. I divided it, right? So then I want to multiply. So when I multiply, 2 times 5 is going to give me 10 on the bottom. Then I subtract. So when I subtract, I'm going to get a positive 1. And so from here, this is going to be my remainder. So I have 5 remainder 1 as the quotient, okay? So we're going to think about this example and bring it into polynomial division. So here, my denominator is x minus 6, so that's going to go out in front. And on the inside, I'm going to have a 2x squared plus a 3x plus 3. So just like we did before, we are going to divide. So how many times does x go into 2x squared? Well, I know that if I were to have a 1 in front of that x, I would need to multiply it by 2 to get to 2. X times x is 2x squared. And if you need to, you can do your scratch work over here. This is what I usually like for my scratch work. So I have a 2x that's being multiplied by my x minus 6. What do I get when that happens? Well, I end up getting that this is a 2x squared minus 12x. And don't forget that you are actually going to subtract. So because you're going to subtract, I'm just going to multiply everything here by a negative 1. When I do that, this is really a negative 2x squared plus a 12x. So I'm going to say that this is subtract my 2x squared plus 12x. So now the 2x squares cancel, perfect. And I have 3 plus 12, which is going to give me a positive 15x. And I bring down the next number, which is going to be a positive 3. So now I repeat, right? So now I'm at the repeat section here. So now I say, okay, x minus 6, how many times does it go into 15x plus 3? Well, x times my 15, a positive 15 will give you 15x. Okay, so let's think about that over here. So I have a 15 times an x minus a 6. What do I get from there? I get a 15x, and 15 times 6 is going to give me a 90, and it's a negative 90. And because you're doing the subtraction, I'm going to multiply by negative 1. That'll kind of give me my subtraction. And so that'll give me a negative 15x plus 90. So I have a negative 15x plus 90. So perfect, the 15x's cancel. If it didn't, something went wrong. So then from here, 90 plus 3 is 93. So then my quotient can be written in two ways. The first way it can be written is 2x plus 15, and the remainder is 93. Or I could have said that this is the quotient as 2x plus 15 plus 93 divided over x minus 6. The way these are written represent the same answer. It means that when you divided everything by x minus 6, your remainder was 93. On your homework, it might want the addition, or it might just want the remainder. So I just want you to make sure that you guys know the difference between the two, which is just really a style for the student or for whoever is asking for the answer. Let's say, Newton, since that's your homework. Now for number 2. So now for number 2, I'm going to rewrite this so I can have it in standard form. That is really important to write there. So standard form. So I definitely still have my 2x cubed, that's fine, plus a 7x squared. But now I need that 0x. That is the term that is missing. And I have a minus 6. So my exponent should be, if it starts at 3, 2, so it's supposed to be going down by 1. So 3, 2, 1, and then my constant. So that's really, really important when I write this. So when I actually compute this, I have my denominator, which is the x minus 7. And I have the inside, which is my 2x cubed plus my 7x squared plus your placeholder 0x, and you have your minus 6. So for the first term, I am dividing. So I'm going to have a 2x squared. So over to the side, 2x squared times my x minus 7. Let's see what I get. Well, when I multiply, I get a 2x to the cubed minus a 14x squared. But since I'm going to be subtracting is the same thing as multiplying by a negative 1. So I really end up getting a negative 2x to the 3 plus a 14x squared. So I have a negative 2x squared plus a 14x squared. Now I'm going to be adding these terms together. So 7 plus 14 is going to give you a 21x squared plus 0x minus 6. So now it's almost like we're starting over again. So, okay, I have to do the division. 1 times a positive 21 gives me a 21, and it needs to be an x. So that I have 21x, that's going to be multiplied by my x minus 7. Let's see what we end up. We end up with a 21x squared minus, and 21 times 7 is a 147. And I can't forget about that x. And since I need to multiply this by a negative 1 to represent the subtraction, then I'm going to have a negative 21x squared plus 147x. So I'm going to have a negative 21x squared plus 147x. So again, the first terms cancel. And now I'm going to have that 147x, and it's going to be a minus 6. So for my next thing, I am going to do my division again. So I need to multiply x by a positive 147 to get to a 147x. So 147 times my x minus my 7 will give me 147x, and 147 times my 7 gives me a negative 1029. So if I were to multiply that by a negative 1, I get a negative 147x plus 1029. So the first terms cancel. If they don't, then that's kind of like telling me you did something wrong. So negative x plus 1029 is going to give you 1023. So I'm going to say that my quotient is 2x squared plus 21x plus 147 plus 1023 divided by what my denominator was, which is that x minus my 7. And so that's going to be my final answer for number 2. So number 3 is very similar. So I'm going to rewrite it. So I really have y to the 3 plus 0x squared plus 0x to the 1 minus 1. That's being divided by my y plus 4. So remember, we need those placeholders. Remember, we need to go from degree 3 to 1 constant. So when I rewrite this, the y plus 4 was the denominator. So on the inside, I have my y3, 0x squared, 0x to the 1, and minus 1. So I'm going to do my division. So I'm going to have a y squared here. So this is my scratch word. Y squared times my y plus 4. I end up getting y to the 3 plus 4y squared. And I'm multiplying everything by negative to represent my subtraction. So that'd be a negative y to the 3 minus a 4y squared. So minus y3 minus 4y squared. So when I add those together, my y to the 3's cancel, perfect. And I end up with a negative 4y squared plus my 0x minus 1. So I'm repeating the same pattern. So for my next one, I do the division. So that's going to give me a negative 4y. So a negative 4y times y plus 4 gives me a negative 4y squared minus a 16y. I'm going to multiply that by a negative to represent the subtraction in my long division. So it would be a positive 4y squared plus a 16y. So again, the first terms cancel. I'm left with a 16y minus 1. So now for that last term, I'm going to repeat my process. So I'm going to be dividing by a positive 16. So I have a 16 times my y plus 4. That's going to give me a 16y, and 16 times 4 is 64. And I am multiplying by a negative, so that I can get a negative 16y minus 64. So negative 16y minus 64. So those cancel, and a negative 1 minus 64 is going to give me a negative 65. So I can say for my quotient that I have y squared minus 4y plus 16 minus 65 over what my denominator was, which is that y plus 4. And that ends up becoming my final answer. Okay. And the other thing that we want to do is we want to divide these polynomial functions. So we have our function f and g, and we want to find the following. See, we want to see what the function f divided by g is going to look like with respect to x. So that's fine. So we have our f function, which is here. We also have our g function, which is here. So our blue and green function, g for green, okay? So my blue function f, that is my, so this is really saying f of x divided by my g of x. So my f function is really 3x cubed minus 13x squared plus 17x minus a 15. And my denominator, which is my g function, my green function, I have an x minus a 3. So this tells me that I'm going to do my long division. So I'm going to have x minus 3 on the outside. And on the inside, I would have a 3x3 minus a 13x squared plus a 17x minus a 15. And just over to the side, I know that this is where I'm going to have my scratch work. So I tend to write a little big, and that's okay. So when I do the division, I'm going to have a 3x squared. So 3x squared times my x minus my 3, that's going to give me 3x to the cubed minus 9x squared. And if I multiply that by a negative 1, it gives me a negative 3x cubed plus 9x squared. So negative 3x cubed plus 9x squared. So perfect, our first term cancels. So I have a negative 13 plus 9, which is a negative 4x squared. And I bring the rest down, so plus a 17x minus a 15. And I repeat the process again. So x into a negative 4x, that's going to be a negative 4x. So if I have a negative 4x, that's going to be multiplied by my x minus my 3. I would get this as a negative 4x squared plus a 12x. And I'm multiplying it by a negative 1. So I end up getting a 4x squared minus a 12x. So perfect, the first terms cancel. So now I have a 17 minus 12, which is going to give me a 5x, and I bring down that negative 15. So now x goes into 5x, a positive 5. So 5 times my x minus my 3 is going to give me 5x minus 15. Now I'm going to multiply that by a negative 1. So I have a negative 5x plus 15. So here, everything cancels, so you don't have a remainder. So your remainder here is 0. So you are going to say that your quotient is going to be 3x squared minus 4x plus 5. Your quotient is, your remainder is 0, so we don't really need it. Okay, and it looks like that is the end for this section. If you guys have any questions, please feel free to email me or the Math Success Center or our in-class tutor. Thank you.